Okay, good morning friends. Today we will discuss with the comparison between the core type as well as cell type transformer. Okay, so here by seeing this winding diagram we can make some differences. Okay, see, here the winding will encircle the core. See here, the windings are covering this core. Okay, so but here, so core are encircle the winding. So this is the one difference. By seeing the diagram we can see the windings here, the winding will encircles, here the core will encircles. Okay, so the next one is the coils. Here the coils are cylindrical type, and here the coils are multi-layer disc type. Okay, so next point is here natural cooling is possible. Okay, we can use air as a cooling medium here, but here natural cooling is not possible. Okay, so due to this core will encircle the winding. Okay, and here the core type is maintenance is easy. Okay, here the cell type is maintenance is very difficult. Okay, and next one is, so this is by seeing this one we can see that this is a single core. Okay, so here we have only one magnetic circuit, but see here we are getting two magnetic circuits. So one is here and another one is here. That's why it is called as a double magnetic circuit, and it has single magnetic circuit. Okay, so here core has two limbs, one limb and second limb, and here core has three limbs, 1 2 3. Okay, so these are the main differences. Okay, and this type of transformer is used in the low voltage level applications. Here this one is used for high voltage applications. Okay, so this is the difference between core type and cell type. Normally in the examinations they are going to ask it for 5 marks. Okay, next concept will be Emf equations. Okay, this is the important concept in the transformer. So by drawing this winding diagram, as well as this is the primary side voltage or flux wave winding. Okay, so this is the graph of the flux, nature of the graph. Okay, simply it is very simple. So normally it is asked for 10 marks in the examinations. Okay, now see here, when you give the supply over here, so the current start flowing through this one. Okay, next concept is Emf equation of the transformer. Okay, so this is the winding diagram. So when the supply is given to primary winding, here current will start flowing through this winding. Due to the current, the flux will start flowing in the magnetic circuit. Okay, so due to the flux in the core, the EMF will be induced in the secondary side. This is the working principle. Now come to the waveform. This is the flux waveform. Okay, so this is the flux productions. At this instant we are going to get maximum flux here. Again it will start decreasing, and again it will go negative, and so this cycles repeats. So this one full rotation or one full cycle is called as time period. So that time period is 1 by f. Half of this is 1 by 2f. So when we get a maximum flux, at that time we have to the time period should be 1 by 4f. Okay, so this is the waveform. Let us study how the Emf equation will be generated. Okay, so now some of the parameters we can see in the transformer. This is the flux production and maximum flux, frequency, and E2. E2 is the RMS value of secondary winding, that is voltage, EMF, and similarly EMF of the primary. So N1 is the primary terms and N2 is the secondary terms. Okay, now we will start deriving this expression. So according to the Faraday's law, average EMF of a per turn is equals to rate of change of flux. Rate of change of flux is nothing but, so according to a particular time, we our flux will be go on changing. So that is seen in the diagram, see in the waveform. So when time increasing, our our flux is also increasing. So this is the meaning of Faraday's law. Now we have to consider this much time. Okay, so the flux changes will be 0 to maximum flux, 0 to flux, and time changing will be 1 by 4. That only we have to take consider for 1/4 cycle. Okay, so for that particular time we have to consider. Okay, for 1/4 cycle, so d flux by dt, d flux by dt is nothing but, so flux changing from 0 to maximum, and our time period will be 1 by 4. So dt is equals to 1 by 4 into 1 by f, that is 1 by 4. This is nothing but frequency. So time is reciprocal of frequency. Okay, so this is the meaning here. So when you solve this one, 4f will came to numerator. Okay, so that's why 4f flux. So now your average EMF per turn will be this one, 4 frequency and maximum flux. Here the flux is sinusoidal, means it is alternating in nature. So we have to consider the form factor. Okay, so the definition of the form factor is given here. Form factor is nothing but RMS value divided by average value. Okay, so this RMS value divided by average value is equals to 1.11, but we need RMS value. We already know that average value. So what is this? Average value is equals to 4 frequency flux. Simply we have to interchange the parameters. So how we will change this RMS value, and we have to shift this average value to this side. So now it will come 1.1 into average value, and simply we have to put average value as a 4 flux m. Now our EMF RMS is equals to 4.44 flux into frequency. Okay, flux into frequency. Okay, so now E RMS is equals to 4.44 frequency into maximum flux. So there are n1 number of turns in the primary side. Okay, primary side we have n1 turns, so we should multiply E1 is equals to n1 into 4.44 frequency into flux. Similarly for secondary windings here, for secondary winding we have E2 and we have N2. So E2 N2 into 4.44 frequency into flux. So this is the EMF equation of the transformer. So we have to write two EMF equation. What is that one? E1 is equals to 4.44 N1 frequency flux. This is first one. Similarly for E2, 4.44 N2 flux. That is second. Okay, so these things we have to write while deriving the EMF equations. Okay, I hope all of you understood this one. If you have any doubts, you can text me, okay, in any way, so in the YouTube or in to my mobile number. Okay, thank you.